This video is about electrolysis with non-inert electrodes. So far the electrolysis that we have studied has used inert electrodes. Those are ones that don't get involved in the reaction. But today we're going to look at what happens if we use metal instead of carbon. So firstly, you need to know the difference between the words inert and non-inert. Inert means that they're not changed during electrolysis. Inert things don't react. But non-inert is the opposite. It means the electrodes do get involved in the reaction. There is a reaction with that metal that the electrode is made from. In this reaction, we have two metal electrodes. On the left-hand side, there is zinc, and on the right-hand side, there's copper. The electrolyte is zinc sulfate. It's zinc sulfate because it needs to contain, in the salt that's dissolved, zinc, whatever the metal is of the anode. The zinc ions will be attracted to the cathode, and there they will gain electrons and turn back into zinc atoms. At the anode, zinc atoms will turn into zinc ions so that they can flow through the electrolyte and onto the copper. This is a time lapse of the experiment. As soon as I switch the electricity on, you can see that the copper electrode starts to get coated in zinc. Look at the zinc electrode on the other side. You can see that the zinc is reacting and becoming part of the solution and then transferring across and becoming a coat on the copper electrode. This is electroplating, using a metal that would be positioned at the anode to coat something else that's positioned at the cathode. So this is a summary of electroplating. What you would do is you'd put a metal that you want to coat another object with at the anode. This means that the anode, the metal will turn into an ion, become part of the electrolyte and travel across to the object being coated at the cathode. At the cathode there are extra electrons, so the metal ion will turn back into an atom and coat whatever it is that happens to be at the anode. The electrolyte that you use has to be a solution that contains the coating metal for this to work. So in order for me to summarise, at the anode would be a metal that you want to coat something with, and at the cathode will be the object that you want to coat with that metal. The electrolyte has to contain the metal in the solution. Let's look at the half equations. Now, if you remember, a half equation is where an atom will turn into an ion or an ion will turn into an atom. So at the anode, what we're going to have is the positive. We're going to take the electron away and leave the positive ion there. The electron is going to travel through the circuit. At the cathode, we have extra electrons, so the electron is going to be gained by the ion, and an atom is going to be formed. I always think about the cathode first because I think that, well, the positive metal ion will gain the electrons because the negative side down here will have those extra electrons and therefore make the atom. So if you remember, the half equation is where an ion, a positive ion in this case, gains electrons and becomes an atom, or an atom becomes an ion, and you see how many electrons that it's gained or lost in that case. Now we want to look at something called purification and how we can use electrolysis to give us some pure copper. Now I want you to look at the two images and you can see that there's two different electrodes, and they're on the top pan balance. And the first one, before I do any electrolysis, the first one weighs 1.95 grams and the other one weighs 0.94 grams. So we have those masses, and then we're going to perform electrolysis. We're going to put one of them at the anode and the other one at the cathode, and we're going to see what happens. Now think about electroplating. We put the electrode that we want coated at the cathode, so that is going to gain those atoms and get bigger, so get more massive. So we need to look, does whatever it is that we put at the cathode gain mass? Now here is a time lapse where we are purifying copper. If we watch carefully, you can see that the anode will decrease in size, and you can see the impurities landing on the bottom of the beaker underneath it, whereas the cathode on the right hand side, that's gaining mass, and you can see the copper through the time lapse growing and as it deposits itself on the surface of the cathode. Now in this case, the electrolyte is copper sulfate. Again, as before, it's containing the metal ions that we want to travel across to the cathode. If we weigh both electrodes afterwards, we can see that the cathode has gained mass and the anode has lost mass. Now, you might think, well, surely they should weigh the same before as after, the mass will be the same. That is absolutely true. The reason why the total mass afterwards is much bigger than before is because they will still be slightly damp and contain some of the copper sulfate solution on their surfaces. So let's look at this in diagram form. So the purification of copper, what we do is we put an impure piece of copper at the anode. Think back to before, where we had the silver at the anode that we wanted, the piece that we wanted to travel across through the electrolyte and deposit onto the cathode. At the cathode, we have some pure copper. Now, what's going to happen is the copper that's in the impure copper is going to lose electrons, become a copper ion, and then once it's in the solution, travel across, be attracted to the negative. It's a copper ion, it then gains some electrons at the negative electrode and become a copper atom again. Once it's a copper atom, it will be solid copper and attach to the electrode, so this electrode will become heavier and it will be full of pure copper. So naturally we need to describe what's going on with the half equations at each electrode. So at the anode, the atoms are becoming ions. They're losing their electrons because those electrons are being attracted by the battery and travelling around the circuit. So here we reduce mass, the anode will get lighter. As those copper atoms turn into copper ions and enter the electrolyte, they'll be attracted to the negative. Once they're at the negative, these positive ions will gain electrons and become copper atoms. So half equation is where we either have atoms turning into ions and showing how many electrons, or we have ions turning into atoms. You can see the mistake there. This is not balanced. I should have a 2 in front of them because 2 plus needs 2 electrons. So what questions do we need to be able to answer from this? We need to know what it means if an electrode is non-inert, so that electrode will take part in the reactions, and rather than looking at what's happening with the electrolyte and the positives going one way, the negatives going the other, we're looking at what happens to the metal ions turning into atoms or atoms turning into ions at those electrodes. So which electrode attracts metal ions? You've got to remember metal ions are positive, so positive ions are attracted by negative electrodes. When they get there, they're going to gain electrons. What conditions do you need for the anode, the cathode and the electrolyte to electroplate something? So the anode will be the metal that you want to plate something else with. The cathode will be the object that you want coated in that metal. The electrolyte has to contain that metal. The conditions for purification of copper, we need impure at the anode, we need pure at the cathode, and then the solution, the electrolyte in between, must contain copper ions.